The Clean Power Hour is brought to you by Continental Energy Solutions. I'm your co-host, Tim Montague. Today on the Clean Power Hour, Superheavy Booster, that ginormous rocket that SpaceX is building, rolls out at Starbase Texas in Boca Chica. World's largest floating wind farm is taking shape off the coast of Scotland. And Japan has signed a deal for 30 10-megawatt power plants, including battery storage and hydrogen plants. And finally, a great story from John Weaver. Do engineers dream of solar panel efficiency? I think that's a little bit tongue-in-cheek, and John's not an engineer, but he should have been. Welcome to the show, my co-host, John Weaver, commercial solar guy.
Hey, Tim, how are you? I would think I would have been a solid engineer. I wasn't that great of a student, but I would have had to recircle back and refocus. But one of the articles in the title we did wrong. We got to give it a little more credit. The Japanese one, they signed a deal to develop 10 solar power projects, or 30 of them, 30 solar power projects. And each project is 10 megs of solar, 10 megs of energy storage, and 30 megawatt hours of hydrogen. And that's pretty cool. I don't know, it's just kind of neat to see so many large things being done in just one deal.
Yeah. Well, it wasn't the first in the roster, but I think we should dive right into that story because it is a pretty unique project. That combination, that killer tripartite of solar, battery storage, and hydrogen. The Renew Economy website doesn't want to give me the story, so bear with me there. But
the internet's not agreeing with you.
No, it's not at all. Maybe we won't do that story first.
Well, okay. Well, we'll get to it. Maybe it'll open it up later. We'll see.
Oh no, I have it here. It's just I guess those electrons are coming to us from Australia, so there's a little bit of latency there. So Marabina Corp, which I've never heard of, has signed a landmark deal with Australian investor Providence Asset Group for development of 30 community-based solar farms. Is this Australia's community solar or what?
I don't know. It looks like this is just going to be a combo investment. Like, for instance, they're looking to invest in selling energy. So, because if you look at it initially, you can see multiple places where they're just talking about selling the solar power and selling it into the grid there, because Australia needs a lot of distributed medium-sized solar plants to deal with their transmission challenges. And then at the end of it, then of course they talk about smoothing the energy that's going to be delivered via the energy storage and the hydrogen. But then there's a hint that they say there's an eye on the potential of green hydrogen exports to Japan. And that's interesting because Japan's, working through its challenges like everyone else, trying to figure out what to do. So I think this is a combination experiment, something. And I was just super interested in the fact that, first off, somebody bought a 30 pack of 10 megawatt farms. That's just cool. Anybody who's got 30 solar power projects going all at once, I don't know, it's just kind of neat. But then they're coupling it with this energy storage and hydrogen, and they're going to offer a more firm energy product by far, and maybe even sell some of this. And so it's a neat little combo of stuff. I mean, I love the fact that somebody bought a 30 pack of solar power plants. That's just cool. They feel safe about the investment. It's distributed. The risk is distributed. Whole bunch of neat stuff. 500 gigawatt hours of electricity. Just kind of cool. So, but this hydrogen thing.
I assume this is going to be hydrogen from electrolysis of H2O. Where are they getting the H2O? I couldn't find that in the story. Do you know?
Not certain. Maybe they'll just pump it in from the ocean.
Well, yeah, they could use salt water. I'm curious about that, right? Because generally you need I think you need desalinated water to do electrolysis with, but
Mhm.
maybe I'm wrong. Maybe you don't. Maybe you can take salt water. I mean, that would make it easier. But
You probably do have to clean it up first. But I don't know that answer yet. It's not referenced. They're probably not going to use gas. I can say that, if only because they're talking about making green hydrogen versus blue, and there's not a lot of gas resources that are sneaking back into Australia. It's getting sold internationally. So, so my guess is that it won't be gas. That's all I got for you.
yeah. And the Japanese connection is simply that they're going to be the asset owner, right? The power is going to be utilized in Australia.
Well, the power, the electricity, but they reference specifically potentially exporting hydrogen to Japan. So
Okay.
yeah, 90% of the value will be generated in Australia. Absolutely. But I think this is a play on the hydrogen stuff. There's there's something going on there, something interesting.
Yeah. Well, as we've talked about on the show, the fact that we have this plethora of solar energy really does make it practicable to take some of that and use electrolysis, take electricity from sunlight, use electrolysis, generate hydrogen that, can replace fossil fuels. And so when you have thermal needs for like natural gas, you can replace that with hydrogen. Hydrogen doesn't quite have the density of natural gas energetically, but it's doable. You just need more hydrogen than you need natural gas. And it's super clean, right? And it's not producing CO2 if you're producing the hydrogen with clean electrons.
Correct.
Which we advocate for. So thank you for that.
Yep. If you ever have anybody that needs to buy 30 solar power projects all at once, let me know. I can help.
Yes, you can. And if you want to go to Mars, Elon Musk can help.
Soon.
What are we looking at here, John? What is this beast?
So if you look down to the right, there's a little dot, like up a little bit. Oh, there's two of those. Yep, right there. Those are called
ants. They're ants. The
yes.
Ants are taking over the Earth.
Correct. 6 foot tall ants covered with gear. So that's the super heavy, I guess. And then on top of it is going to be a rocket ship. And that's the one, that's a big old rocket. And it's apparently full of a whole bunch of Merlins, and they've got to fire off in patterns. And I guess that's the new stand that it's going to sit on. But, I think there's 2 or 3 sections or 4 or 5, and each one of them has its own rockets, and they'll fall off. And I don't know exactly how this one's going to work, but
this is one ginormous booster. I know a little bit about this. The engines all sit at the base
for the whole thing. It doesn't fall away. There's not layers within this.
No,
one.
this is not a multi-stage booster. This is one stage you're looking at, and the engines are sitting down here in the bottom. There's going to be 32 or 33. Apparently they haven't decided if it's 32 or 33. And I'm like, how could they not know at this stage of the game if there's 32 or 33? But anyway, the test launches of Starship, which is the rocket that sits on top of this, had 3 engines. And so 33 is a very big number. And I just hope it doesn't go boom, because that is going to be a very big explosion and could get them in trouble. That's my concern about Starbase, which is the name of this whole facility now in Boca Chica, Texas, is that they've started to rub up against, the state. And even though Texas is a very freewheeling state when it comes to things like this, and that's why Elon loves Texas, because it's as libertarian a place as you can get really in America. I think they're running into some environmental challenges, right? They're right there on the coast. That means there's a big wildlife area right there. And, people are understandably concerned about the environmental impact of firing all these rockets and the debris that falls when the rocket explodes, if it explodes, which experience will tell us it does explode. Uh, so,
Well, we can also say that there haven't been any Falcon explosions in a long while.
that's right. They are launching and landing the Falcon 9. It's almost weekly now. It's become such a regular thing for them to be launching the satellites, mostly for the satellite internet service that you and now I did put a deposit now on Starlink. Because I was traveling in my RV and I realized that, when I don't have good cell coverage, my life comes to a screeching halt. And so I need Starlink. So Elon, step on the gas. I want to give you my $100 a month for a Starlink subscription.
A lot of people do. I think they have about 500,000 people on their list. I have a feeling I'm going to be a person who will end up rescinding because the density, they only want to give out so many. And it may not be smart for me to take a spot from somebody who actually needs it. And so I've got home internet. I'm cool giving them the $100 and using it because, it's not that much more. But it may be a more prudent thing for me to actually not use it. So that somebody like you who actually needs it can use it.
Yeah. I hear you. And I'm curious how they will throttle subscriptions so that they don't overwhelm the service. Interestingly, they're also going to do a test with Starlink on this July launch of the Super Heavy. They're planning to launch the Super Heavy with a Starship on it in July. So they are ramping up. And the one that we saw the photo of is not the one that's going to launch. They're building another one that's going to actually launch. But apparently when the booster is landing, there is a phenomenon which I don't understand at all. So I'm skating on thin ice here, but it causes a blackout of radio service to the booster.
Mhm.
And so they're going to do a test with Starlink communicating with the booster, which you can appreciate that it might be easier to get to the booster from space than from a cell tower or something like that. So
Okay.
anyway, Starlink
whenever capsules fall in from space, there's minutes of terror is what they would call them, where it's just blackout, where there's no signal for those folks. And so if this is associated with that, that's pretty cool. That's pretty cool.
Yeah, we'll have to do our homework on what that is. Not that it's super relevant to the clean energy economy. It's more relevant to those of us among us who want to go to Mars. And
Tim,
I want humanity to go to Mars. I just don't want to be among them.
It's relevant, Tim, because it's cool.
You are Mr. Cool, John. I have to give it to you.
No, the rockets.
Cool.
The rockets are cool. I'm just John. I'm just a solar guy.
Well, speaking of cool, do engineers dream of solar panel efficiency, John? That's the question.
I've actually been given an answer, and we may get them on the show now, but they do.
Who's they?
They specifically, in this answer, is a member from the Hunt 1366 team.
Oh, cool.
So the Hunt perovskite team, which is located in Bedford, reached out to me, and I may get to visit their facility, shake some hands, talk to smart people. I even nudged them that, hey, if they want to get a little press on your show, give us a follow up. But so what this article is about is really just, there were two more perovskite 30% solar cell announcements in the same week. And, I'm a science fiction dude and love all kinds of neat stuff. I've talked about perovskite on this show once every 3 weeks, probably. Yep. Everybody's probably getting tired of it. But two companies came out, Jinko Solar, and I even maybe mentioned this last week.
Yeah, last week we talked about the Jinko story.
Day later, 1366 Technologies notes that they have a solar manufacturing facility they're hoping to build in India, 2 gigawatts of capacity, manufacturing capacity. And they merged with a company, 1366, who's been around for a while, has not done very well for themselves yet, but they're still digging along. They got something. This perovskite company, they're still testing stuff. Now they've decided to come together, which is weird. Two companies who've yet to really deploy into the world, but they're still, hammering. And so this purpose of this article was first to kind of sum up the three big people we see doing it: Meyer Burger, Jinko, this 1366 Hunt thing. But then to also, and that's the second half of the article, do a little math on what might be the benefit. And I based that on a Longi Solar article, white paper they put out, where they showed the balance of system falling 7% when they increased by 11% in panel efficiency. So they have an analysis for a 380 watt module versus a 425, 45 watt gain, 11.8% change. And they find that in total, land call, piles, brackets, modules, cable, combiners, fixed brackets, they go through all the little components and say, by going up in efficiency by 11%, the project costs drop 7%. And if we drop 7% for going up by 45 watts, when we go from our 20%, 22% panels, and we pop on a 27% panel, a 30% panel, we're going to go up by 57% of efficiency, which might be another 30 to 40% drop in balance of system savings. So imagine your 2 meg system, which was, $1.50. You can drop it 30 more percent just because the panels are so much more efficient. Your labor costs are lower, your everything, your system is cheaper. And that means cheaper electricity for the customer. And also, I went into it a little bit, but it also means less land being used, less equipment for installation, fewer machines, fewer transport. And, of course, it'd be sweet as heck if we suddenly had a whole new round of technology for all the companies in the world to pound against. And so I just, that chart right there, that's going from the 380 to the 425. Can't wait till we go from a 425 to a, I don't know, 550, 600, something like that.
Oh yeah.
Whatever the number is.
Yeah. I mean, Trina is selling 550 watt modules in the US now. So
Yeah, but they're big. Imagine a 550 at a standard 72 cell.
yeah. Yeah. The physical format of these larger wattage modules is bigger.
Yep.
So what I'd like to revisit here also is P-type versus N-type. And when you Google what is the difference between P-type and N-type, one of the stories that comes up is this story right here, which is by Kelly Pickrell at Solar Power World from 2018. Okay. And there's a nice graphic though, showing basically that, P-type dominates currently. And then you see the rise of N-type here in the top, and that includes TopCon by Meyer Burger, right? Yep. And interestingly, what I learned from that article was that N-type was the original technology at Bell Labs was an N-type technology. The difference is boron versus phosphorus is used in the doping of the silicon. But so here we are, and N-type is coming back, and you notice though that perovskite or hybrids aren't even on here. I don't think.
Yep.
And so just in 3 years, right now we see the advent of perovskites getting commercialized, and that is going to be transformative, and ultimately probably the entire industry will go that way.
I'll tell you what, even this chart is off in 2 big ways. N-type has come on much, much faster. And heterojunction would be all over it nowadays. There's heterojunctions on this chart. Perovskite might be on it within the heterojunction, but it doesn't get its own subclass in the charts I've seen. But N-type has come on fast. And what's going to happen, like an article I'm hoping to write in the next couple of weeks, is somebody did a techno-economic analysis of perovskite cells on top of various normal cells, because that's how it's going to work. We're going to take our perovskite and we're going to find the best solar cell we can. And then we're going to put the perovskite on top of that. And a lot of these people are using N-type TOPCons. So I have a feeling what's going to occur is that N-type TOPCon is going to keep getting developed, and it's going to just be awesome. And it's going to be what for the perovskite tandem cells have to compete with, because the mono PERC is already getting left behind. It's N-type. It's going to be TOPCon probably, and the TOPCon is going to be topped with this perovskite product. So that's what I see coming. And I'm gonna have a neat article on the cost between each of them. But in essence, this one analysis said they're going to cost the same, even a little bit less from a cell standpoint, just literally the cost of the cell, 22, 21, 20 cents per watt. They see no reason for it to be any more expensive. So looking forward to perovskites, looking forward to N-types, all the cell, the learning curves on cells. It's just really cool to watch these days.
Yeah, it's a fast moving world. You really have to pay attention to stay on top of it. So it's great to have you in our midst, because I know that you are doing that.
Love it. Love it.
We have a project of the week I'm going to bring on screen here.
What a nice system.
This is a school project that we built last year called Woodland Elementary, developed by Siemens. We've been doing a lot of work with Siemens Solar Development Group in Northern Illinois, and they're doing PPAs with schools. So we're using Talesun 385 watt modules on this project. And what was the inverter? I forget. I will bring that up. They're using Yaskawa 60 kW, Yaskawa Selectra 60 kW inverters. This project is interesting because, to us anyway, we had a big learning curve on the placement of the modules in relation to the beams in the roof, the purlins, right? It was very, very challenging to make the design work, so to speak. We ended up with a very beautiful design. As you can see, it's very symmetrical, and it did work out, but we had to be very creative. We ended up using AP Alternatives racking, which is well known in the ground mount space, but not so much in the rooftop space. But so for this flush mount, 800 kW of it's a shingled roof. This is by far the largest school project for rooftop for flush mount that we've done. We've done some bigger flat roof projects on like high schools, but very nice elementary school. And we're going to see a wave of, we already have the first wave of these school projects has come to Illinois. This is through both the Adjustable Block Program and the Solar for All program, which is the low income parallel universe for solar incentives. And we're about to get a second wave with the Omnibus Energy Bill. We're just holding our breath until that can get passed. I learned that the Illinois legislature, both the House and the Senate, can vote remotely now. There was a thing where they had to vote in person in one of those chambers. I'm not sure which it was. And now they can all vote remotely. And so that's going to make it possible to get a quorum going, hopefully in July, but if not July, August or September. So there's the project of the week.
Nice. A flush mount, hard attached, 792 kW. That's a lot of human labor. lot of focus on the workmanship there.
Yeah, I wish I had the number of hours of manpower, so to speak, that project took, and I don't have that. But indeed, good workmanship and clean energy jobs. That, I was listening to a podcast with Saul Griffith, who was one of the co-founders of Rewiring America. When we make the transition to a electrified economy, okay, Rewiring America is not just about cleaning the grid, but cleaning all of industry and transportation. We're going to save consumers $2,000. This is just in the US, $2,000 a year by making that transition. So while the upfront investment is $1 trillion a year for 20 years to do this transition that we need to do to stop climate chaos, it's going to generate significant ROI. The other interesting factoid about that very big plan, which I will revisit hopefully on the solar podcast in the near future, is that, in the World War II investment that we made was something on the order of $150 billion. And at the time, how do we measure gross economic output? The GDP was about $100 billion. So it was like 1.5 times GDP. And that transition that Rewiring America has analyzed is on that same scale or slightly lower. So, if we can do it to stop the Germans in World War II, we can do it to stop, to save our butts, to save humanity from having to constantly fight the floods, fires, and other natural disasters that nature is going to just feed us in greater and greater mouthfuls. But I digress. Let's get on with the news. We've got a great story from Electrek here on floating wind. I wanted to say floating solar, but it's a floating wind project.
Yes. And so it might be the third floating wind project in the world, but it's the second big one that's running. So the first one is high wind. It's about 25, 30 megawatts. I think it's 25 or 30. It's 5 or 6 megawatt units. Some mix of those two. This one's 50 megs. It's 4 or 5 9.5 meg units, and then 1 2 megawatt unit that's kind of been there for 2 years. They just floated out the last one. They're mooring it to the ground, and it's cool. It's 50 megs, so it's not like a huge plant. It's not going to change the world, but it's not trivial relative to Scotland's size and Scotland's energy usage. And it's also not trivial because these are 9.5 megawatt floating units. So these are like full on next generation floating units. It's not trivial in that it's the second large plant that's going out. There's another one, I think, off the coast of France that's like 9 megs. It's 2 smaller units or 3 smaller units, something like that. Maybe Portugal. So this is the second one. It's doubled the size of the first one. And man, if we can get our handle on floating wind, we have infinite energy. Not infinite, but close damn enough for argument's sake, relative to what matters. So it's pretty significant, I think, to see just the next one coming. That means the first one worked. And so now the second big utility scale offshore wind facility is going to get vetted, and it's going to be off to the races, dude. It's going to be off to the races, gigs and gigs of floating wind, hundreds of gigs of floating wind around the world. It might be that wind turns out to be the largest electricity generation source on the world, on the planet. I think solar is going to win out because it's so distributed and so small, but maybe wind could like really change things.
Yeah, I was listening to Chris Nelder's podcast recently. His most recent podcast is a recap, or it's like a best of, and he brings on 5 different guests from previous shows. And he had a scientist on, I'm not going to remember the guy's name, but from a university in Finland that's done an analysis of similar to Electrify or Rewiring America or the 2035 report, but on a global basis. And these guys concluded that solar was going to be 70% of grid power in something like 2050.
Okay.
And it was strictly about the economics of the technology and how easy it is to make solar distributed. That one of the challenges that they touched on with wind is that you need really good transmission because the wind power isn't necessarily close to population centers. And they talked about high voltage DC, for example, which they're definitely using with these offshore projects and others. And so it is a thing. It's just that solar is so super abundant, and you can distribute it more than you can distribute the wind power. So wind will continue to be a major force. Now, and this is just a model, so who knows what reality will bring. And today, aren't wind and solar pretty much going head to head in terms of the installation on an annual basis?
Yeah, so technically, maybe for the first time, no, I mean, solar has been deploying more wind or more capacity than wind for a little while, a few
Yeah,
years, maybe 2017,
but
18.
only by a few gigawatts, right? It's not like a major delta.
No, now it's like a major delta, I think. I think solar is like 120, 150 gigs, and wind is like 190, 80. Like wind only caught up with solar after solar was pulling away for a while. But it just so happened that global capacities crossed each other, like total installed somewhere around 600 gigs each is where solar passed wind, and now solar is accelerating because we're going to have like 200 gigs of solar installed next year. It might be 100 gigs of wind. Like solar is going to be doubling up wind soon.
Yeah.
And wind needs to pick up too, though, if to hold on to its portion. But wind has like double the capacity factor of solar. So, and this offshore stuff has above a 50% capacity factor, especially during the winter times. I mean, the first winter of the high wind project, it was 65% capacity factor.
Yeah. So I just Googled that question. So I found a chart that I'll put on screen here. And this is, I gotta move.
Hey, there you go. Yeah, look at that. See?
This comes from PowerWeb, and it shows that 2019 was kind of a tipping point, or 2020,
Yep.
where global solar exceeded global wind installations, and now solar is pulling away.
Yep.
With 1,300 gigawatts they're predicting in 2023. So it sure does look like the solar is accelerating faster than the wind here, which is not a bad thing, John. You and I work in the solar industry, and you can't complain. It's a rocket ship ride. Did you see that story, by the way, about the potential capacity from China of solar being, exceeding global demand in 2022? There was a prediction now.
Well, I saw a prediction that just on PV Magazine, literally within the last hour or so, was a prediction of 100 gigs in China alone. And the rest of the world might be about 100 gigs. I think the rest of the world will be a little stronger than 100 gigs next year, but maybe about the same. So I haven't seen the underlying why. I think it has to do with distributed solar finally taking off in China. Prior, it had been 90% utility scale. Now they're starting to shift into distributed. For instance, I saw something talking about every new rooftop is going to start requiring some degree of solar. Every 50% of existing government buildings, solar, et cetera, et cetera, et cetera. So there's there's some volume that's going to come there. And I've seen other stuff suggesting that getting close to 400 gigawatts of capacity will be available come the end of this year. So, the pricing of polysilicon going up caused some challenges. And I don't know if those numbers will still be fulfilled, because I heard that Jinko Solar might slow down their capacity expansion a tiny bit. So if that's the case, maybe that means we'll only have 300 gigawatts of capacity. And if that'd be still pretty sweet, because this year we're expecting anywhere from 160 to 180, to be deployed, 150 to 170, somewhere in that range. So yeah, 100 gigs, one country, dude. How cool is that? Just like 2 years ago, that was the world's capacity getting deployed. So that's kind of neat.
What I don't understand is, why is that growth in demand causing overcapacity?
Well, no, there's two things. There's growth in demand that's occurring within the country, and then there's growth in manufacturing capacity separately occurring. And China, within China, there's smart people looking at both equations, saying, okay, if we're going to force these companies to grow their volume that they're manufacturing, we're going to have to soak up 50% of it, because somebody there has a logic for their manufacturing, for their industrial policy, deploying and manufacturing. There's two different groups that definitely are talking to each other. So maybe it's them, I don't know exactly what the equation is, but there's a driving capacity. It could be that knowing that the demand is coming is leading to a scale up in capacity faster than the demand is ready to absorb yet. So maybe that demand is driving over capacity manufacturing somehow. But whatever, I know there's going to be hundreds of gigawatts deployed per year for the rest of our lives. How's that?
I'm looking at this story and I'm struggling to get to the bottom of why there's this overcapacity, but we'll have to give it a deeper dive next week. But speaking of wind, Maine has decided to ban offshore wind. What's the deal there? That doesn't sound like a good thing.
Specifically, they banned it within the 3-mile state water window.
Okay.
For the fisher persons, and the lobsters.
Yeah.
And they said all offshore wind will be 3 miles and out in the federal water.
And do you know, in the greater scheme of things, John, though, is 3 miles a big distance for offshore wind, or is that like, oh yeah, no big deal, we'll gladly put our turbines 5 miles offshore?
So I didn't know until I asked Dr. Christopher Clack via Twitter. He runs Vibrant Energy. They're a big modeling group.
Yeah.
They have the coolest models that I know of for modeling the power grid. And you should get that guy on the show. He's cool. He knows all kinds of stuff. And
well,
so
you'll have to hook us up, John. Come on.
Yeah. Get on the show, dude. He said they don't model anything within 6 kilometers. And 6 kilometers is 3.7 miles.
Mm-hmm.
So he doesn't even model 3 miles out. And let's look up the vineyard.
But wait, meaning he doesn't even look at the wind resource more than 3 miles offshore?
No, the opposite. He doesn't look at the wind resource within 3 miles.
Okay.
Goes the opposite direction.
And the assumption is that the wind resource is better the further you go offshore, I assume.
Or the assumption is that's where it's going to get built.
Yeah. No, I can appreciate this, and obviously the fishing industry and the lobstering industries are major economic forces in a state like Maine, and you don't want to mess that up. So,
Yeah. So Vineyard Wind is 15 miles from shore.
Wow, that's far.
Yep. So there you go. So maybe this is a good nuance. Maybe this is a good trade-off.
Yeah.
Something to You know, that's cool. I mean, on the one hand, it's like, damn it, why are you banning this? We like this, governor, but you know, you got to work it. And you know what? I think floating wind and offshore wind is going to lead to more fish, more mollusks, more everything. And eventually the fisher professionals are going to be like, oh, look at this. We got new fishing areas. Now we're going to have to force new wind, and we're going to ban, I don't know, they're going to ban not fishing around. They're going to start.
I think that is a thing, right? That when you build a structure offshore, it does become an island. It becomes an ecosystem. It's like an artificial reef.
Yep.
Right. And then you get all this sea life around it. I wanted to mention, though, this article calls out the fact that there has been a 50% decline in surface krill. Krill are tiny shrimp that animals like whales eat, and due to warming waters. So global warming is threatening ecosystems in a myriad of ways, including water temperature, ocean acidification, right? There's more CO2 in the atmosphere that's getting into the ocean water and acidifying. And then the little sea animals can't make their shells, which are made out of calcium carbonate. And so, you know, we got to do everything we can to help those ecosystems, but putting wind offshore, further offshore, is probably not going to stop these ecosystems from facing major challenges from climate change, right?
Yeah, there's going to be some challenge, no questions asked. We're not going to save anything, but maybe this will help a little. And you know what? If the trade-off isn't that bad, then I got to pat the back of all the main politicians who did some smart work.
Yeah. And speaking of climate change, there was a man-made disaster off the coast of Mexico, I believe, right?
Yeah. Gulf of Mexico.
In the news last week, and the ocean is apparently on fire right next to a drilling platform. What's the story here?
So this is an oil drilling platform. It also gets gas at the same time. And there's a gas pipe that was leaving the platform, and it caught on fire. And I mean, look at that, dude. Are you serious? Like, we set the, I'm not supposed to cuss. Do we have kids who listen to this show, Tim? Because
I hope so.
Yeah. We set the ocean on fire, dude. Like remember that time we set a river? Well, you don't remember, but there was a river we set on fire a whole bunch of times in Ohio, and then suddenly we did it one more time, and it was really bad. Well, dude, we set the ocean on fire. I mean, the thing, water, the giant thing, was just burning. There was so much, just crap in it. You know, 1,000 people died in the heat wave. And that has really upset me. 1,000 Canadians and Americans. You know what? A whole bunch of them were old folks in British Columbia who didn't have houses with air conditioners because they live in freaking Canada, dude. And Canada set new record temperatures similar to Las Vegas and Phoenix. Like 110 degrees.
Yeah, it was 120 degrees in British Columbia, all-time record hot. And apparently they've just been setting that record year after year for the last couple of years. So the drumbeat of rising temps is continuing, and humanity has to smell the coffee and make a wartime effort to stop climate change. There's just no ands, ifs, or buts about it. The writing is on the wall. It's time to act. And as Greta said in I'm fond of following and quoting Greta Thunberg, the Swedish environmental activist. She said in a TED Talk recently that it's when we turn to action, John, that there is hope. And I totally resonate with that. It's like I feel really good about being part of the clean energy economy because we're doing something about the problem. The problems are myriad, the problems are many, the problems are very big, and they can be overwhelming if you just wallow in them, right? But if when we get into action, then we have hope that there is actually light at the end of the tunnel. So if you're concerned about climate change, get into the clean energy space, get into clean tech, because it's a rocket ship. There's tons of jobs and economic opportunities. And as Jigar Shah says, a $1 trillion wealth creation opportunity, a very unique $1 trillion wealth creation opportunity is upon us. It's good for capitalism. Speaking of capitalism, how can our listeners find you, Commercial Solar Guy?
They can find me brooding, thinking about all this challenging work we got and what happened in the Northwest last couple weeks. And they can type it into Google, Commercial Solar Guy. I'll be there. I'll be on LinkedIn. I'll be on Twitter. You can give my office a call, 508-49999-SUN, because that's my number. And we general contractor in the Northeast. We're developing even further, all the way down to Mid-Atlantic, all the way down to Virginia, Pennsylvania. We got a phone call in from a Pennsylvania customer who was listening to the site, listening to the podcast. So I thought that was kind of neat, Tim. I'm really glad that you folks find this stuff educational and informative. That's really neat to hear. So thanks for reaching out. And type me into the internet, John Fitzgerald Weaver. I'm all over it.
I love it that you branded yourself as the Commercial Solar Guy, and it's a great brand. So stick to your guns. Not that John Weaver isn't an excellent brand as well. You're the only John Weaver I ever heard of. So I think there are more Tim Montagues than John Weavers. I've managed to clone myself more times than you. That's my claim to fame, John.
You're working hard. Okay.
So you can find me at cesnrg.com /podcast, where you find all of the Clean Power Hour content week in and week out. Today is episode 51, which will drop tomorrow on Friday, July the 9th of 2021. And so check it out. Please subscribe to the channel. Give us a thumbs up. You can also find us on audio only podcast platforms like Apple Podcasts, Google Podcasts, Spotify, and give us a review, share it with your friends, and please comment. We've been getting some great comments on YouTube. I want to thank those commenters who've been giving us feedback. One of the comments is they want to hear more about microgrids and virtual power plants. So
Okay.
let's do that, because those are great topics. And that's the thing, is we listen. We are such good listeners, you and I, John. With that, I will say sayonara and let's grow solar and storage.